Hello guys, and welcome to another video. Okay, so this will be a continuation of the alternating current tutorial video. Okay, so this is going to be very concise, simple, and then straightforward. Okay, we look at the various subtopics with their respective how do we call it, the formulas. Okay, formulas in solving questions. I've already told you that, or informed you that aside the DC current, with the AC currents, it's all about formula work. Okay, once you know the formula, once you know the concept, you are good to go. Okay, so let's dive right into this. Okay, so now let's first look at what sinusoidal voltages and currents. Okay, so in AC circuits and voltages and currents, we have what sinusoidal voltages and currents. Okay, so let's say we've been given the voltage, okay, to be the Vm, okay, sine of a sinusoidal, okay, that's why we have a sine, okay, t, okay, so we have that, and then we have what we could represent this in this form, okay, Wt, okay, it's not normally pronounced as Wt, okay, it's something like this, okay, can be further, okay, simplified into what 2 pi, okay, 2 pi f, okay, so this is equal to what 2 pi f, okay, keep this in mind, okay, sometimes you meet certain questions, you need to what derive these formulas, okay, so it could be either written as V because Vm, okay, equals what the sinusoidal, okay, so sine of 2 pi f, and then you bring your t, okay. Now, so we know that Vm, okay, our Vm is our peak voltage, okay. Vm is our peak voltage. Vm is peak voltage. You know, most definitely F will be what frequency, just like our alternating current calculation. We got what to calculate frequency with what a certain time, okay, we found what average value, okay, and the root mean square value, okay, and then we know that what angular, what this is our angular frequency, okay, angular frequency, right. Let me short this one up. So we have what angular frequency. Now note that this could be further simplified, okay, so we know that the V is equal to the peak voltage sine of what angular frequency times what the time, okay. So now let's see, we already know that V, okay, V, that's the root mean squared, okay, root mean squared is equal to what the peak voltage, okay, divided by what root of 2, okay, so the same applies to what the root mean squared what current, okay, is equal to the same as peak what, yes, you are right, the peak current, okay, divided by root of 2. So now note this could be further simplified as the root and what the peak voltage, okay, to be equal to what root mean squared voltage, okay, multiplied by root of 2, okay, and this could be also further simplified as peak what current to be equal to root mean squared current, okay, to be equal to what peak what current to be equal to the root mean squared current root 2, okay. It's just simplification. We are trying to what change subjects, okay, because we'll be implementing what them in subsequent calculations, okay. So we have that. These are the formulas you need to know, okay. The ones I'm circling are the main formulas you need to know, okay. Right, so we have that, we have this formula right here, okay, we have this formula too right here, okay. These are the main formulas you need to know, okay. They are used basically in calculations, okay. I've already told you that AC currents is all about what formula work, okay. So once you know the formula and you understand the concept, you are good to go, okay. So now let's take what a simple example, okay. So example 1, okay. So we are told what find the root mean square, okay, find the root mean square values, okay. Let's say you are told to find the root mean square values of the following the following quantities, okay, the following quantities. Sorry for the handwriting, okay. You are most focused on the calculation, okay. So now let's say you've been given A to be equal to I, okay, a certain I to be equal to let's say maybe 10 root 2, okay, and then we have sine of what? Angular frequency, okay, angular frequency, or let's say let's put in values over here, okay, let's put in values over here. So now we have what? Let's say we have sine of 100, okay, 100 pi t, okay, 100 pi t, and then maybe our B, another question is what? A certain V, okay, this is I, okay, and this V, okay, so we have a certain 20 what? Sine of let's say similar thing, okay, by t, right? So now let's see how we can solve this, okay, let's see how we can solve this. So we have a solution, okay, have a solution to be equal to, so once we've been given something like this, something like this, and you are told to find what the root mean square values of the following, it means that we have to find what root mean square current and then what root mean square voltage, okay. So from here, from this example, we could notice that we can find what the root mean square. This is the formula for finding root mean square, okay. That's the peak voltage, okay, divided by root 2, okay, and then we try to make what the peak voltage the subject of this. That's why I stated that for alternating current question, all you need to know is the formula, okay. Once you know the formula, you are good to go, okay. So now you could notice that these questions are written in this format, okay. You could notice that the voltage is written in this format, and what the current, okay. So you could also write the same thing in what current, okay. So we have sine of what 2 pi f what t, okay. So you can notice that we can write it in both voltages and in current, okay. So from here you can notice that this is the same as for the first example, okay. You know that I is equal to what 10 what root 2 sine of 100 pi t, okay. We could notice that this is the same as, this could be written as what? Yes, sine of 2 pi f t, okay. So from here you could notice that our peak current, okay, our peak current is equal to what 10 root 2, yes, 10 root 2. So now we could just find out our root mean square what current, okay. So our root mean square current, we know that is what the peak what current divided by root 2, okay. That's how we find our peak root mean square current, okay. So we have what 10 root what 2 divided by what root 2, okay. So this is the formula we are using. Take note, this is the formula we are using, okay. So we have what root 2, and then when you simplify this further, this will cancel that, root 2 will cancel root 2, then we have what 10, okay. So 10 will be our root mean square current, okay. Note that this has no unit because we are dividing what current by current, okay. Now let's proceed to the what root mean square voltage, okay. So from here, these are A and these are what B, okay. So you know that V equals to what 20, okay, 20 sine of 100 pi t, okay. So now, so from the same principle, we know that V is equal to what Vm, okay, sine of 2 pi f t, okay. So now we know that Vm is most definitely what 20. So finding what? VRMS, okay? Root mean square voltage is the same as what? 20, okay? So from this formula, okay, we know that Vm is equal to what? Vm on what? Root 2, okay? VRMS, okay? VRMS is equal to what? The Vm on what? Root 2, okay? So we have what? Our Vm, which is 20 on what? Root 2, okay? So that will be our what? Root mean square voltage. So you can further simplify this to get what? 21 root 2. Let's see. Okay, so this will give us 14.14, okay? Right. So from this same calculation, you could be told to find what? Your frequency, okay? The same question, you could be told to find your frequency, okay? Yes, because you know that 100 pi t, okay, should be the same as what? 2 pi ft, okay? So you can just find your frequency, okay? So let's say you are told to even find what? Frequency from the same expression. So you have what? 100 what? Pi t is the same as what? 2 pi ft, okay? So finding frequency over here, we know that our frequency will be equal to what? Let me change the color so that you get to understand. So we know that t will cancel t out, okay, and then pi will cancel pi out, leaving what? 100 on what? 2, okay? So our frequency will be what? 50 hertz, right? Right, 50 hertz, okay? So we have what? 100 on 2, that's what? 50 hertz. So the same applies to this portion. We'll get to know that our what frequency will be also what? 50 hertz, because it's the same thing. So 100 pi t, okay? Sorry. About 100 pi of t should be equal to what? 2 pi ft, okay? So we have what? T cancel t, pi cancelling pi. So we have what? F to be equal to 100, okay, on 2. That's also equal to what? 50 hertz, okay? Now, so that's how you solve for what? Such, sinusoidal questions, okay? So whenever you meet anything of that sort, this is how you go by it, okay? So now let's move on to what? Harmonics, okay? Let's move on to harmonics, right? So let's say harmonics, okay? Let's move on to harmonics now. So as already stated, we are concentrating on what? The calculation portion, because there's no way you'll be asked to define what harmonics is, okay? You could be asked to even either explain, okay? So per explanation, you go by what? The explanation, you just explain, okay? So for harmonics, we have what? The general harmonics, okay? And then we have what? The root mean square frequency of what? Harmonics, okay? So let's say we have what? A certain what? Voltage in terms of time, okay? To be equal to what? 4e, okay? 4e on what? Pi, okay? And then we have a certain long expression, okay? Maybe sine of 2 pi, okay? ft, okay? And then we have what? Plus of 1 on 3, okay? Sine of what? 6 pi ft, okay? And then we have plus. So harmonics could be, series of what? Series of these sinusoidal voltages and what? Sinusoidal currents, okay? So you could notice that we have the same sequences, okay? So let's take this example. So we have something like this. These sequences repeating themselves, okay? Right, so let's proceed, okay? Let's proceed. So we have this, okay, sequences repeating themselves, okay? So you have what? 1 on 5, okay? Sine of what? Let's say 10 pi ft, okay? Let's end it here, okay? You could continue, okay, we could continue, but let's end it here. So these are harmonics, okay, so they are a series of what? Sinusoidal voltages or sinusoidal currents, okay. So this is how we represent these harmonics, okay. So they are sequences, okay, so they are series, they are continuous, okay, with a similar pattern, okay. So now let's see how we can find what these harmonics, okay, using our what root mean square. So we have what, using our root mean square formula, okay. As stated earlier, once you know the formulas, okay, alternating current calculation becomes simpler, okay. So for alternating current, unlike direct current, all you need is what, the formula, okay. Understand the formula, understand the concept, and you are good to go, okay. So let's say you have what, root mean square of what, of harmonics, okay. Root mean square of harmonic frequencies, okay. Harmonic frequencies. Now let's proceed. So we know from initial stages you got to know that what, these are how we represent what, harmonics, okay. So let's say you've been given what, let's say you've been given a series of what, voltages. So let's say V equals what, you've been given a series of voltages. So how do you find what, your root mean squared current, okay, or root mean squared voltage? So it could be represented in this form, but this is how you write the general formula, okay. So you have A what, naught squared, okay, plus A1, okay. So we start from A naught, we move on to A1 root of 2, okay, all squared, okay. Since I already stated that they are in what, sequences, okay, they are continuous, okay. So that's how we represent the entire formula, okay, plus what, A3 root of 2, okay, squared, okay, plus A4, okay, it's just continuous. So okay, we could continue like that, okay, just like that, right. So now this is how we represent the general formula for what, the root mean square of what, harmonics, okay, just like in this form, okay, just like in this form. So let's say you've been given an example, okay, an example problem, okay. So let's say you've been given what, 2 plus what, 5 sine of angular what, frequency, okay, T plus 3, okay, this is 3, okay, let me write it well, okay. Let's say I have 3 what, root of 2 sine of what, open bracket, 3 angular frequency plus what, 30 degrees, okay. So these are phases, okay, these are phases. This is what we refer to as what, phases. We will dive right into phases in a bit, but I want to just introduce it to you before we get there, okay. So that's what we refer to as what, phases, okay. So now let's proceed. Now, so let's see how you can solve for what, your harmonic. So let's say you are told to find what, the total harmonic, okay, of this entire what, current, okay. So let's say we have that, okay. So we have what, I, okay, these are I, okay. So let's say you are told to find what, the total harmonic in this sequence, okay. All you have to do is just use your formula, okay. So this formula, I'm referring to this formula, okay. So this is what, A naught squared plus A1 on root 2 all squared plus A2 on root 2 all squared, continuous like that. So from the principle of what, from this assumption, okay, how you were able to what, compute, okay, compare and contrast to notice that. So this is a general formula. So when given an example and then we compare it to the general formula, you notice that some correspond to others, okay? So the same thing is what we'll be employing over here, okay? We employ the same principle over here, right? So we have sorry, let me just go back, okay? So we have a general formula, okay, with a general question, okay? So all you have to do is just compare and contrast, okay? So now let's proceed. So we have what a naught squared means that this what corresponds to this, okay, and then this entire corresponds to this entire corresponds to that. Is what continues. In case we had others, it will correspond, okay? So now this is how you solve it, okay? So this is what I, so let's say in case this was I, this could be what I, okay, and could be also what V. It depends, okay? So but this are I, so this is how we proceed in solving, okay? So this is what a naught squared, so these are what a naught, so you have what 2 squared, okay, plus what a1 what on root 2 what all squared, so these are what a1, okay? So you have what 5 on what root 2, okay, all what square plus what you have a2 root what 2, so this what a2, okay? So you have what 3 root 2 divided by what root 2 all squared, okay? So when you compute all of this, when you punch this on your calculator, you end up with a certain value of 5.05, okay? Right, so this will be what your harmonic what current, okay? So now let's take another example. Let's say we have what example what 2, and then we are told to find what the harmonic voltage. Let's say we have a certain voltage. We have 5, okay, plus what maybe 6 sine of what the angular frequency t, okay, this is 6, right? Then we have plus what 6 roots, let's say 2 sine of angular frequency, okay, and then plus maybe let's say 5 on root 2 sine of 3, okay, let's say this is 5, okay, this cannot be 3, okay, it should be 5, okay, yes, so we have what 5 angular frequency t plus an angle of maybe 45 degrees, okay? So take note, this is an example, okay? Now let's proceed. So the same principle could be used, okay? So let's say this is our solution, okay? So we start from what are V, these are what are A, okay? So from here we have what are A naught, so we have 5 squared, okay, plus what 6 on what root 2 all squared plus 6 root 2, okay, so 6 root 2 on root 2 all squared, okay, plus 5 on root 2, okay, we have what 5 on root 2 divided by like root 2, okay, all squared, okay. So let's try finding the answer for this. Let's try computing answer for this. So when you punch this, when you punch the entire of this in your calculator, so let's take what our next topic, which is what phases, okay. So we have what phases, okay, this is what phases, okay. So in simple terms, when we talk about phases is all about what how we represent sinusoidal what quantities to avoid drawing the sine wave, okay. So sometimes you will need to draw sine waves, okay, you need to draw some sine waves and all that, okay. Sorry for how I initially drew it, okay, but you need to draw these sine waves to represent your sinusoidal quantities, but we could represent our phases. Okay, we can be represented, these sinusoidal quantities could be represented in, okay, so this is how we represent phases. Okay, they are represented by an arrow, okay, an arrow pointing in a specific direction. Okay, now, so phases have angles attached to them. Okay, so specific angles attached to them, and then whenever we say that the phasor is out of phase, it means that it has a specific angle, just like this one. Okay, but whenever a phasor is in phase, it means that it has no angle. Okay, it means that the angle is 0. Okay, so whenever it has a phasor has a phase, it means that it has a specific angle. It could be any angle. Okay, it could be 30 degrees, 45 degrees, it doesn't matter. Okay, so now let's proceed. So let's see how we represent phases. Okay, so how to represent phases. Okay, so now in case we've been given a certain sinusoidal voltage of this format, okay, with respect to time, okay, and then you are told to represent these two sinusoidal voltages and current on a phasor. Okay, this is how you go by it. Okay, so let's look at the solution. Okay, let's look at the solution now. Right, let's proceed. Okay, so this is how you represent these two sinusoidal voltages and current, sinusoidal voltage and current on a phasor. So first, we know that you have a certain 240 root 2. Okay, that's what we refer to array. Let's move back. I want to reference something over here now. So that's what we refer to as peak voltage. Okay, and peak current, peak voltage, and then peak current. Okay, so now let's go back. Right, so these are peak voltage, and these are peak current. So now let's see how we represent that on a phasor. So now this is a peak voltage of 240 root 2. Okay, so this is how we represent that. So these are 240 root 2. Okay, the reason why this is a straight line is because it has no angle. Okay, but for the current, we could notice that it has a specific angle of minus 30, so we represent that one too. But for 240, for a peak voltage of 240 root 2, it has no current attached to it has no angle attached to it, so we could state that it's out of phase. Okay, it has no it's in phase because it has no current. Okay, so now we've finished representing our sinusoidal voltage with our peak voltage. Okay, so now let's look at how we can represent our sinusoidal current with respect to time with our peak current. Okay, so our current is 10 root 2. Okay, so 10 root 2 means that we have a specific current, but let's consider the angle. The angle is minus 30. Okay, so this is our number line. Okay, let's say this is our number line. Okay, these are positive, these are negative. Okay, so we notice that the angle will lie downwards. Okay, so let's say these are 10 root 10, 10 root 2. Okay, 10 root 2, so the angle theta, okay, that's negative 30, will lie over here. Okay, so these are negative 30 degrees. Okay, so this is how you represent our phases. Okay, this is how we represent phases. Okay, so let's take another example. Okay, so that you get to understand it better. Okay, let's say we have a certain v of t to be equal to let's say you have 240. Okay, 240, let's say 240 sine 100. Okay, sine 100 by t. Okay, and then we have a certain angle. Let's choose an angle, maybe 30. Okay, so let's put it in this format. Okay, now, and then we have a certain current. Okay, to be called maybe let's say 40. Okay, 40 root 2. 2, okay, sine of let's say 100, okay. This is just an example so that to broaden your scope, okay. Minus what, let's say 45 degrees, okay, this degrees. So let's see how we can represent this on a phasor, okay. So let's first draw our phasor diagram, okay. So this is how we represent that. We know that this is positive, this is negative. So now we have what, 240, what, positive 30. So let's say these are positive 30. So this is how we represent positive 30. This is positive 30, okay, positive 30, and then we have what, 240, okay, 240, that's our voltage, peak voltage, and then we have what, 40 root 2 with what, negative 45, okay. So negative 45 could be something like this, okay. So these are what, negative 45, okay, negative 45 degrees, okay, that what, 40 root 2, okay. Right, so this brings us to the end of this video. I hope you enjoyed this video. Kindly subscribe, like, comment and share, okay. Like the video so that it will get passed on to other students who would like to also be enlightened, okay, on this same topic, okay. Subscribe, switch on the bell icon so that you don't miss out on any uploaded video, and I'll see you in the next video. Bye bye.